Hello guys, welcome back to part 3 of Xilinx Vivado Design Suite quick walkthrough. In this video, I'm gonna continue where we left in part 2. So I have closed the design just to show you this thing that I have mentioned before. If you have already an existing project, it's gonna show you a recent projects in this area, right? So if you remember in part 2, we have created the project named project underscore one. So when I open the Vivado GUI, it is showing me the recent project. So if I'm just gonna click it, it's gonna open my recent project. Okay, so here we have our project in which we created a file called example.v, and I think I have discussed everything like what options are, what and what they do, and what we can take out of them. And I think I missed this guy, this window. This window is kind of like a dynamic window. It's more like properties, but it's gonna give you a lot of information about files and IPs and everything. Okay, so let's just get started from the example design. So we have created this file through, when we just created the project, a window popped up and it was asking about the module name and the ports, right? So if I double click it, that's the window in where the project summary is basically the Vivado editor. It's more like just a text editor. So if you don't like this editor, what you could do is like you can use your own editor and you can edit this file wherever this file is residing, right? For example, we have created the project in projects folder. So if I'm gonna show you this guy, that's the projects folder in my D drive, and that's the project name. So as I said before, like once you create the project, Vivado is gonna create a lot of files, right, in different directories. So that's the main project file, which is called XPR file. The extension of this file is XPR, which is Xilinx project file. Okay, you can see here the Vivado project file. So the good thing about this file is basically you can see like there is a Vivado icon before the name of the file. So if you are gonna double click it, it's gonna open the project directly into the GUI. But the good thing is like is is basically that is a XML file, and you can edit this file in any of the text editor as well. And what's the benefit to do it? I will tell you later. Like sometimes we are gonna add some files without like touching the other files. So if you're gonna add the file in the GUI, so most probably Vivado GUI is more like it will relocates the file locations in the project. And if you are concerned about what you had previously and now what you have changed, and if you're going to compare the new version of your XPR with the old version, it's gonna messed up a little. Why? Because it will give you a lot of like differences, but actually you don't have that differences. Maybe at this point you are not able to understand what I'm saying right now, but it's more like a professional thing. So for now, we are concerned about just the walkthrough of interface, and we are just gonna create a simple example design here, and I will take you to every single step of the flow, and then I will generate the bit is just simple bit stream and will download into the device. Okay, so if you see here, we have the projects under project underscore one dot srcs, which is the sources file. If you go inside it, that's the sources one folder, and that's the new, and that's the same file that we are seeing here, right? So if you have any like editor right now, I don't have any editor. If I'm gonna open this guy, for example, if I'm gonna just open it in the notepad, so it's gonna show me the same thing. For example, okay, so The thing is like there's the same file that we have created through GUI, but the thing is like it's just a file with the extension .v, so we can add it anywhere. So for example, we are gonna generate some code inside of this file so that we can simulate our example design, and we can synthesize it and implement it, right? So if you remember, we actually defined these ports through our GUI, right? If you remember, like I had set up like 7 bits, 0 to 7 bit of data in, and same 8 bits data out. So what we are gonna do with this module, for example, I can add it here or I can add it here. So some part I want to add it here so that I can show you like what happens like if I add it outside of the GUI, outside of the Vivado GUI, what is gonna happen actually, right? So the first thing is like 8 bits a little bit more, so I'm gonna change it to 3. So it's gonna be 4 bits data in and 4 bits data out, and I'm gonna make it a register, right? Reg, and then I'm gonna type always at pose h, and I'm gonna speed this up a little. And then I just control S, which I just saved it, and then I'm just gonna close this notepad editor, right? And going back to the Vivado GUI, right? Right now, what happens is like you notice this file has changed. So if I click reload it, then it's gonna reload. Right now, it's showing the previous version of the file because I didn't reload it. So once I clicked it, then it's gonna reload it, right? So and the asterisk mean it's still not saved here. So if I just again control S, it's gonna save the file. Okay. So, and there is no syntax error because I have typed it like very accurately. There is no typos or anything, right? So that's the first source file. Okay. And what I did here, I just created a 4-bit register or a flip flop, you can say. Okay, so the thing is like what I'm gonna do right now is I'm gonna create a test bench for it so that we can simulate this guy. And I just clicked on the simulation sources, and that's, as I mentioned it before, like every time in the simulation sources you're gonna have all your source file, but right now there is no test bench. So what I'm gonna do, if I can add the sources from here, or maybe I can just right click on it, or just add sources and select this, create the simulation sources, and next. And because I don't have any files, so I cannot just add it, so I need to create it. So just need to type the name, so test bench tb, and the example, which is the design name, and just keep the local directory for now. And the file type is we are gonna code in Verilog. Okay, so I just keep the Verilog and then just finish it, so it's gonna create the file. And if you remember, it's the same module pop-up thing, like it is asking like, okay, this is gonna be your module name because we defined the file name before. Okay, and the same thing like IO ports. But if you know Verilog a little bit, if you're a beginner, maybe you don't know it, but if you are a little bit familiar with the Verilog thing, so in the test bench we never define our ports, right? All right, it says like module definition has not been changed. Are you sure you want to use these values? Yes, I'm sure. Right. Okay. And then what is going to happen? Like it's updating the design, and now we have two files at the same hierarchy, right? So what I'm going to do, I'm going to double click on it, and then I can add it the test bench here. So I'm going to type very quickly. So I'm going to speed up the video. All right, guys. So I have just typed a real quick test bench. What I did here, I just created the four signals. One is the ratch clock, right? And I initiated the clock with 0, and then I just generated like 100 Mac clock, like the time period is just 5. So just made a forever loop, and the clock is assigned to the toggle of its own, right? And then I just created a reset, like initiated with 0, and then after 10 nanoseconds is gonna be I don't know, it's a nanosecond right now. Whatever the scale it is gonna be that. Yeah, that's the nanosecond, so it's gonna be a nanosecond here, okay? And then it's gonna be 1, and then again 0, and after 200 is gonna be 1 again, and then 0. And these three blocks are basically, they are non-blocking assignments, so they're gonna run in parallel, right? And then in the third block, I just made a third block for data in. The data in initialized is initialized with 4B000, and then it's gonna start the loop forever. And then what happens is, like, every after 40 nanosecond, data is gonna have a data in plus one value. So it's gonna initiate with 0, and then it's gonna be 1, 2, 3, and so on. All right, once it hits the 1, 1, 1, 1, and then it's gonna be again 0, 0, 0, 0. Okay, and that's the instantiation part. So this is the name of our module name, and that's the instance name. And then we just use the port assignment as it is, like the clock is connected with this clock, reset is connected with the reset of test module, and then data in is connected with this data in, data out is connected with this data out, right? I just made the exact same names, but we can have a different name. Like here, instead of clock, we can use this clock, or reset we can just say RST, or data in is just dat in, dat out, whatever, right? Okay, so the third thing, because for the simulation, I think we are done. So what I'm gonna do in the simulation, in the Flow Navigator, we do have a simulation option. So if I'm gonna click the Run Simulation, it's gonna give me one option, which is Run Behavioral Simulation. If I'm gonna click this guy, it's gonna start the simulation. Okay, first is elaborating the design, and then it's gonna start the simulation executing, right? And that's the waveform. So the thing is, the unit for now is, it's showing me like 1 0 0 0 0 0 0 picosecond, but actually it is 1000 nanosecond. If you remember, in the settings we have this guy, right? This guy. So this is like how much is gonna run, okay? But the unit is picoseconds for now, so it looks like a very big value, but it's not. It's exactly the same thing, right? So how we're gonna check like it's working or not? So that's our test bench, and that's our module. And then just scroll left to see the waveforms, and zoom out a little bit, so we can see like what is going on. So if you see here, so what happens is basically we did something wrong. What we did, basically, the thing is, in the test bench, basically we didn't define like how long the data in and data out are. So what I'm gonna do now, so I'm just gonna close the simulation and go back to our test bench file. Okay, and then I'm just gonna fix it. So the bus width was 320, and then this guy is gonna be 320 as well. Okay, I'm gonna save it, and then I'm gonna run the simulation again, and this time this should work. Okay, so the same steps, like if I just click it, it's gonna be zoom fit, so it's zoom fit. Okay, and what I'm gonna do is, that's a thing, like l- zoom a little so that you can see what is happening. So we generated the clock. So if you see this guy here, that's the 10 nanosecond clock, which is 100 mag. Okay, and then we reset the design for like that's 300, which means like this guy, and I think I can add a cursor. Okay, so that's one thing, and then that's the another marker or the cursor, so you can see like that the reset is started from 10, and then it actually go down at 30 nanoseconds, right? So at that period of time, the output is just zero, and then there's no reset, so whatever the input is gonna be on the output, right? And at some point we actually have the reset again, right? This guy at 230, and it's gonna be 20 nanoseconds long, so it's 250. And that period of time, whenever the positive age comes up, what happens is like the data is zero, right? At this positive age, the data is zero, data out is zero, and at this positive age, the data is zero. But at this positive age, there is no reset, right? If you zoom a little, there is no reset anymore. So whatever the data in is going to be on data out. And if you notice, as I said, like data in is just incrementing the way I made it 0, 1, 2, 3, and so on, A, B, C, D, E, F, and again go back to 0. So that's how we simulate in the Vivado, and that's the Vivado simulator. For now, I'm going to close the simulation here. And what I'm going to do, okay, so it is asking me to save the waveform. So if I want to save it, then eventually next time it's gonna load the same waveform whatever I have saved, right? So just save it so that we can just see the extension of the waveform. So it's gonna it put the name by itself, like TB example behavioral simulation dot WCFG, which is waveform configuration file. Okay, so just save it in the project, the same project. So right, okay, and then it's just closing the simulation. Okay, so that's the third thing, the RTL analysis. Okay, I in the previous video I mentioned like in the RTL analysis, what is gonna happen is like we can see the schematics. Okay, it's gonna just elaborate the design without like synthesis or implementation. It's just gonna elaborate. So if I'm gonna open up the elaborate design, I can see the schematic. So I just click on it, and then it's gonna reading the NAT list. Why? Because it's just elaborating the design, in fact, right now, initializing the device, loading the device. So it's gonna give you the schematic. So you can see like we do have a clock port, we have a reset, and then we have a data in, and then we have data out, right? And these are the register that we have coded. And you can see like these are the 4-bit register or 4 single bit registers, whatever you want to take. Okay, the good part is like you can do zoom in zoom out here. It's very easy if, for example, because that's a very simple design, so it's already zoomed in, right? But for example, if you do have a lot of design, how you're going to zoom in, there are like options, right? That's the zoom in, zoom out, and that's zoom fit. But there are shortcuts, like you can just click on it and drag, and you can zoom, right? And the second thing is like what's the quickest thing to zoom out? So just hold the click and go to the right upper direction. That's the zoom negative, right? And if you want to just fit it, then just hold the left click and just go to the left up direction, so it's going to be zoom fit. And the same thing, zoom one, or you see is going to change. So that's how you actually do things, right? So it's very cool feature, I really like it. Okay, so that's the schematic. I'm going to close it now. Okay, and then the fourth step is to do synthesis. But before doing synthesis or implementation, what we should do is like add the constraints file. Okay. So the thing is like to add the constraint files again, you can go through the add sources from here, or you can just right click on it and then just click add sources and then add or create the constraints. Okay. Next, and then I'm going to create the file with the same name as my design. Okay, so example, and it's gonna create example.xdc. XDC is Xilinx design constraints. Okay, and then I'm gonna finish it. All right, so the file is gonna be under the constraints underscore one directory, and then I'm gonna double click on this file, and then it's gonna open up in the editor. Okay, come on. All right, so what we need to write here, that's the point. As I mentioned before, like in the constraints, we have to specify like which pins are gonna be connected on the ports of our module. Like this clock, it's gonna connect physically somewhere, right? Same thing applies to this reset, is gonna connect physically somewhere, and these two guys as well, right? So in the XDC file, we have to provide this information so that tool can place our design and then connect with the physical buttons or switches or LEDs or the clock, right? So to I mean, what information you're gonna write. So as you know, I am using Zing 7000 Zybo Z720. So what I can do is like go to the browser and Zybo 7020 XDC, right? I can find this file here. Okay, so that's the Digiland master file. Okay, so you can find out like it's on the vendor website, Digiland Inc. So that's the master uh, file, XDC file for the device. Right now I do have this device. So what I'm gonna do, I'm gonna copy all, not because it does have every pin informations, and we don't need everything right now. What we need is just the clock signals, switches, buttons, and LEDs. So I'm just gonna copy these guys from here, and then I'm gonna paste in my XDC, right? So all the files are all the lines are commented out right now. So what I'm gonna do is like remove the hash so that we can have the files. So we can have the lines. So the thing is like this line is a property, set property package pin. K17 is the name of the pin, and it's defining the standard, like input output standard is LCM OS33, and then get ports. And when it says get ports, it means like what port you are actually gonna connect, right? So in the design, we have the clock with the name CLK. So I am gonna write here CLK, right? That's the port I'm gonna connect with this package pin. Okay. And then the second thing, to create a clock, that's gonna be a virtual clock. I mean, it doesn't mean like you are actually gonna create the physical clock inside the device. The device itself, it has some clock. So this clock is more like a virtual clock. And when I say virtual clock, it means like the tool, I mean the Vivado tool, it's gonna meet timing, or it's gonna do routing and everything, and it's gonna use this clock as a reference, right? Okay, so this is the create clock command, and that's the name of your clock. And the port, again, you have to connect this guy with our design port, which is clock. And we are gonna run, we want to run the design at 100 mag. So I'm gonna define the period 10 here, and the waveform switch is basically 0 to 5, and again 0, and then 0 to 5, and so on, right? Is like that. Okay, so after that, so that's the one thing we have done for the clock. And for the reset, what I'm gonna do is I'm gonna use buttons, right? We don't need all four buttons, so I'm just gonna delete the rest of the lines, and then this is uncommented. And then I'm gonna connect this guy with the reset. Okay, and then the inputs data in, because that's the 4 bit, so we have to connect every single bit with the pins. Okay, so we're going to connect these guys with the switches. So just delete that, delete that, delete that, and then instead of SW, I'm gonna say it's a data in, and then it's data in pin 1, it's data in pin 2, and it's data in uh, pin 3. And the same thing is gonna be for data out. So I mean, the point is, whatever the ins and outs of your module, the main module, you are gonna connect everything physically in your device. Okay, so that's the output are gonna be connected with your LEDs, so you can see visually what is happening. So instead of LED, I'm gonna say it's data out bit 0, data out bit 1, data out bit 2, and data out bit 3. Okay, that's how you generate or create your XDC file. Okay, and just gonna save it. Okay, and now you have the example design, and for this file is just for the simulation. So these two files are actually your are gonna be useful for your synthesis and implementation. Okay, so now the fourth step is basically your synthesis. So what I can do is like I can start synthesis from here, or I can start synthesis from here. If you just right click on it, you can just click on launch run, or you can, so this option, I mean from here, it's gonna start whatever the active run is. For example, if you do have two runs, right, like synthesis 1 and synthesis 2, and then whatever the active, this option will run the active one, not all of them, but you can run actually all of them one by one. Okay, so the thing is like right now, just for the simplicity, I'm just gonna click on this guy, and it's gonna again ask me the same thing like I showed before: number of jobs and launch runs on local hosts and generate scripts only and whatever. So by default we should be good, so we just click OK, and it's gonna start synthesis. Okay, the thing which is noticeable here is, as I mentioned before, in the log tab, we have three tabs, like in the simulation, because we just close the simulation, so we are not seeing anything here. But if I click synthesis, you can see the log is going on. Like it is writing, Vivado is writing everything, whatever it is doing right now in the synthesis. And now the simply synthesis is done. Why is that so quick? Because, it's just a 4-bit register. Okay, so now we do have three options. Like we can just directly run the implementation, or we can just open the synthesized design from here, or we can view the reports. So we can just do any of these things, or we can just cancel it. What if I just cancel it? If I cancel it, then what we can do, like we can start the implementation from here or from here, or what we can do is like open the design first, like open run. So if I click open run, it's gonna open the synthesis run here. Okay, it's the same thing like you can see gnats and you see leaves and everything. It's probably when we are debugging stuff, we do use this guy most of the time. And this is basically again the same as I told before. Like this is the properties window, so it's a dynamic window. It's gonna give you a lot of different informations about like files, IPs, NATs, and everything. So it's very useful window actually. So if you notice, like in the synthesis open design, it is giving you general information, properties, options, logs, reports, messages, everything. And these logs is basically the same here, right? And reports, whatever the reports generated while it was doing the synthesis, and the messages like warnings or informations or any errors or whatever, right? These are coming from all the synthesis run. Okay, and that's the general, like the name of this run is synthesis 1, the part it used, and the active part is that, and the description is just the Vivado synthesis defaults, and constraint it used is this, and it ran the synthesis on this directory. So if we can go and take a look on this very quick. So that's the project, right? And that's the waveform we saved. And if you just go to projects, project underscore one dot runs, you can see there is one new folder created, which is synth underscore one. If you go inside, you can see there are a lot of files, and that's the one which is right now is opened here. And this is called the design checkpoint. What you can do is like you can open another instance of Vivado, and then you can just open this DCP separately if you really don't want to open this the design inside your project, right? So you can do that. And another thing I have mentioned before is the script, right? When we were like you remember like when we were because it's already implemented, so already synthesized, so it is asking like you really want to rerun it. So if you remember, there was a pop-up window and then it was saying like generates scripts only. So that script is basically this one. So that's the name of the design, and that's the tickle script. So if I double click on it and then open in the notepad, then it's gonna give me the script, right? And that script is basically what it actually did well when it was doing synthesis, right? So that's the script. So we can just generate this script, and then we can use this script in another instance of Vivado or in known project mode or whatever. Okay, it does have some purposes. Okay, let's get back to the GUI, and then just we can close this synthesis design now so that we can do implementation. Again, we can, okay, so now in the previous video, we had all these options disabled, and that time because we didn't have any synthesized run, so we cannot generate any of the reports. But right now you can see like we can report time, we can generate timing summary, clock networks, clock interactions, methodology, DRC, utilization, power, schematic, everything, right? Whenever you click on any of these, is going to generate a report for you. Okay, so I'm not going to open any of the report for now. So I'm going to implement the design. So I can just click on this guy, and again, this the same thing. You just, if you just want to generate the scripts or you want to launch on localhost. So I'm going to run uh, the implementation on my local machine, localhost. So just click on it, and then in the logs in the implementation, now it's going to give you implementation information. Okay, so it's just gonna it's just started. So you can see it's just started running Vivado with arguments log example dot. It generated the script, and then it sourced the script, right, with no trace. Okay, so it's gonna be it's not going to take a while because again it's a very small design. So and the thing is like if you click on this run, this window is going to give you the information of this run. If I'm going to click this information is going to give you that information about the run. Okay, the same thing. And if I'm going to click on this file, you see this window has changed to source file properties, and then it's going to give you the information about this file, where it is located, it is enabled in the design or disabled or whatever. So this is very dynamic window and very useful information. Okay, so it has completed. Now it is asking the same thing, like you want to open the implemented design. It's going to look like the same as we saw in synthesis, or you are going to generate the Bitstream, which is basically the next step, or you want to see the report. So if I just select this guy and click OK, so I don't need to click on here. Or if I just click cancel, then what I can do is like just click the generate Bitstream, and it's going to ask me the same thing again, and then I'm going to click OK. So now what happens is like it's generate Bitstream is basically the step, the additional step in the implementation. So before you saw like it was done, but when you click generate Bitstream, it's actually started again. So what happens is like implementation, it it is divided in kind of like three steps: optimize design, and then place design, and then and then route the design. And when you click generate, it's gonna divide in four steps, right? Optimize, place, routing, and then generate bitstream. So this guy basically it has four steps, right? Okay, so now the bitstream has successfully generated. Okay, and then again, same thing. You want to open the design, you want to view the reports, or open hardware manager, or generate memory configuration file. Okay, so I'm gonna click. I can also select and click OK, but just to show you guys, I just click on cancel, and then I'm gonna open the Vivado hardware manager from here. Okay, so this is a very useful tool inside of the tool, which is the hardware manager. So why we use it? We use this hardware manager to download our bitstream into the file and to debug the stuff, right? I mean, whenever you have the ILA core or virtual IO, you can use the same hardware manager for that too, right? So right now, what happens is like I have my device connected to my machine. So if I'm gonna click this open target, it's gonna detect my device automatically, right? If I just click on it, it's gonna ask me like open new target or auto connect. So because I have the device connected, so I just need to turn it on so that it can detect. Yeah, I just turned my device on, and then I just gonna click on it auto connect, and it says like connecting to server, which means like it is actually connecting to the device. Okay, so you can see here it has connected with the device. Okay, and it says like the device name is this, and it is not programmed. And because that's the Zybo, so it does have the ARM processor. But here what we need to do is like program the device. Like we have the bit stream, we have generated the bit stream, and the bit stream was actually generated in the IMPL, right? That's the project, that's the runs in IMPL. The bit stream is generated somewhere here, example dot bit. That's the bit file. Okay, so the thing is like to program the device, you can click here, or you can right click here and then program the device, whatever you would like to do. Okay, so I'm just clicking this program device, and then it's going to ask me, okay, where is the bit stream? So automatically wherever it generated the last bit stream, it's going to give you the same path, like D projects, project underscore one, project underscore one dot runs, IMPL1 example dot bit. It's automatically it is loading this file. And if we have the debug codes, then we are gonna upload uh, a LaTeX file here. But right now we don't have any debug codes, so I'm just gonna skip it. Okay, so that's the example dot bit is now gonna be on your device. Okay, so I'm just clicking on program. So it's not going to take a while because the bit stream is really small. So now it's just programmed your device. Okay, so that is the device I'm using, that is Zybo Z7. And these are the four LEDs, and these are the four buttons, and I have put the reset on here, right? So right now there is no LED blinking. So what I can do is like if I just this, so that is that, and this, and that, and this. Okay, and the reset is here. So if I just click on this guy, it's gonna reset it, and then whatever the inputs are here is gonna be on the outputs. Okay, all right guys, so that's it for this video. I think we have almost covered everything so far. We have seen, just to summarize, we have seen the basic functionalities, and then we have created example design, and we have seen like how we can simulate within the Vivado, and then how we can synthesize, and how we can implement, and then how we can generate, and then how we can program the device. Okay, so the thing is like in next couple of videos we are gonna start learning other stuff, and then uh, a lot of things I know I have skipped here in this video, but in the next videos, I am gonna go in details, every options like these options. I didn't cover these, especially reports and our runs and everything. And when we will discuss like timing analysis stuff and other basic topics in the digital designing, then we will cover everything. So for this series of videos, I'm kind of done. So hope you have learned from these three videos. Thank you so much.